Hello ladies and gentlemen, we're on to 1.1, solving literal equations. Okay, our objective here is to solve literal equations, which is a fancy way to say formulas, for one of the variables. So literal equations, just to say it again, these are just simply formulas. Okay, I'm sure you've seen formulas in various math classes and science classes before, so no big shock here, hopefully. However, formulas don't always have the variable you're interested in alone on one side of the equal sign. Okay, so for example, if you're interested in the temperature, which is T in the equation I have next, which of these formulas is nicer, assuming that we have numbers for all the other variables. Okay, so this is PV equals nRT. This is what's called the ideal gas law. You've maybe seen it in chemistry. But regardless, okay, if I have numbers for P and V, and then numbers for N and R, and I want to know what T is, I could plug them in here and plug them in here. I'd have to work them out, and then I'd have to solve for T using my equation solving stuff. Maybe that sounds good to you, maybe not, but this equation I've got the T by itself, and if I plug in numbers for P, V, N, and R, all I have to do is crunch the numbers over here, and I already have the T by itself. So in my opinion, this guy over here is much nicer. Okay, now granted that is an opinion, but sometimes it's a lot handier to have that letter that you care about all by itself. Well, in order to rearrange these formulas into nicer forms, we'll use the same steps we use to solve equations. Well, so let's compare and contrast the following two problems, and in both cases we're going to solve for the variable m. I think that's pretty obvious in the first equation, not so obvious in the second, but here we go. Okay, for the first one I have 5m equals 35, and of course that means 5 times m. Anytime I have a multiplication like that, in order to cancel it, to get the variable by itself, I'm simply going to divide by whatever that multiplication is. In this case, I divided by 5, but of course I've got to do that on both sides of the equal sign. So those two cancel, leaving the m by itself, which is what I want, and then here I just have to figure out 35 times 5, and that's 7. So easy enough. Okay, when I come over here, I've got a times m equals g. So I do still have a multiplication by m, and I've got some other thing over here, g. Okay, now remember, variables just stand for numbers. Okay, we just don't happen to know what those numbers are at a given time. So, same basic steps apply. If I have a multiplication, I use division to cancel it. So same thing over here, I have a times m, multiplication, so I'm going to divide by a to cancel the a's. Of course, just like in the other equation, I have to do the same thing to both sides. So I divided by a here, I divided by a here. Okay, as we said, those guys cancel, leaving us the m all by itself. Okay, and now I have to figure out what g divided by a is. Well, I don't know what g divided by a is because those are both letters. Of course, if I had numbers, I could actually divide them, but I don't. So all you do is leave the g on top, right where it is, put the a on bottom, right where it is, and that's just as far as you can go. So in this particular formula, m equals g divided by a. And now if I was told what g and a were, I could easily figure out m. So the basic idea is that you do whatever steps you would do if there were numbers, but you won't have the numbers to actually add, subtract, multiply, or divide, so you just leave the letters alone. Okay, so again, just another example to stress things, what's going on. I've got solve equals x minus c equals w, and whatever this formula is, I want to solve for the x. So again, this is the guy I want to get by himself, so I want to cancel out everybody else that isn't the x. Okay, in this case, it's x minus c, so, well, that's a subtraction right there, so I better do an addition to cancel them out. Alright, again, the whole point is those guys will cancel, leaving the x by itself on the left side of the equal sign. And over here I've got w plus c. And again, I have no idea what those numbers are, so I can't do anything but write that w, whatever he is, plus the c, whatever he is, and that's as far as I can go. Alright, so maybe it seems a little bit weird, but that's what you got to do. Alright, let's take another example, just to get a little bit of practice. Please try to predict what I'm going to do before I do it, but whatever the case, follow along and see how it goes. Alright, so let's try to solve for m equals g over w for g. Okay, now don't get thrown if the variable you want is on the right side of the equal sign instead of the left. Same basic process applies. You just take a look at the equation you have, and you do whatever you need to do to cancel the other letters that are there. Okay, so g over w, of course, means g divided by w. So I'm going to multiply by w on one side to cancel the w's, and of course, multiply by w on the other. Alright, so again, these guys cancel, so it leaves me with g all by itself here, and then I've got w times m. So you could just write that as wm. Of course, since it's multiplication, the order doesn't matter, so you could write it as mw. And then looking at what I have here, granted this is a good formula because the g is by itself, but maybe you're like me and I like the one I care about to be on the left hand side. So I would personally rewrite this as g equals w times m, like that. Alright, the ones we've done so far have been one-step equations, so let's take a look at one that's going to be more than one step. Alright, so again, I've got my formula here, at plus v equals s, and I'm going to solve that for t. Alright, so again, the t is the one I care about, so I'm looking at them right here. Alright, so I've got an a and a v on the same side, so those are the ones I got rid of. And again, if you're a little bit confused, change the letters into numbers, and then just ask yourself what you would do. So instead of at plus v equals s, again, I'm going to leave the t being a t, but I'm just going to replace the other guys with numbers. And I'll just be very uncreative here and just use 2, 3, and 4. So I'll say 2t plus 3 equals 4. Well, if this was my equation, the first thing I would do is get rid of the 3. So coming back over here, the first thing I'm going to want to get rid of is the v. So let me just recopy this for clarity's sake. So that's an s. I'm going to write it in cursive. Alright, so the first thing again is that thing being added. That's what I want to get rid of, so that's what I'm going to do here. Minus v on both sides. Boom. Again, the v's cancel. That's what I wanted to have happen. So now I've got at equals an s and v. Well, those are two different letters. They're definitely not like terms. So just leave it as s minus v. Okay, same thing here. If I would have subtracted that 3, I'd be looking at 2t equals 1. Okay, well in this case, whatever letter is attached to the, or whatever number is attached to that letter, I need to divide by. So in this case, I would divide by 2. Likewise here, the a is the thing I want to get rid of, so I'm going to divide by him in order to get the t by itself. And just be careful when you're dividing, you have to divide the entire side. Don't just do one or the other, make sure you do both at once. I just like to make a big fraction bar and throw the a underneath it. Works for me, and hopefully it works for you too. Alright, so now the t is by itself, and then like I said, I've got s, v, and a. I've got 3 totally different letters, so there's really nothing I can do with them. So just leave it as s minus v over a. Pardon my s being a little bit sloppy, but now the t is by itself, so that basically is what lets me know I'm done. Alright, just a little more practice here. Solve p equals 2l plus 2w. You may recognize that as the perimeter formula for a rectangle, but we're going to solve that for l. Alright, so again, the l is over here on the left hand, or the right hand side rather, and so I want to get rid of everybody else. So I've got a 2, I've got a 2w that I have to get rid of, and again, just like the last problem, if I've got some addition or subtraction going on, that's what I want to get rid of first. So I'm going to subtract a 2w from both sides. Alright, now again, the whole point is those two guys cancel, so I'm left with a 2l over here on the right. And on the left, again, I've got this situation where I've got different letters, so there's really nothing I can do other than recopy them in the order that they are. P minus 2w. Okay, now at this point, again, if I totally ignored the left side here and just look at the right side, I want to get l by itself, and I've got the 2 attached to it, so I need to divide by the 2. Alright, again, those two guys cancel, and now I've got the l by itself. And over here, really, I've got this mess of stuff that it really doesn't look like anything happens so much, and it doesn't. However, you might be thinking, hey, what about those two 2's? And if you are, I'll explain what's going to happen there and what you can do if you want to. But I've got this equals L, or again, if you like me, you like the variable that you're interested in on the left-hand side, so just really recopy it in reverse order. P minus 2w over P, that's a good answer as well. But if you'd like, okay, I've got L equals, in case you wanted to go with this route, instead of a big fraction bar with a 2 underneath it, if you wanted to, you could write it as 2L canceling with a 2, and then P minus 2W over here. You could divide by 2 on each of these terms individually. Having these two 2's cancel, leaving the L by itself. This P over 2 leaves me with not a whole lot going on, so I just recopy him. And then here, you might notice, hey, I've got the two 2's, so yes, they could cancel for just a single term like that, so then it'd be minus W as well. Okay, now this is a little bit unusual, but basically I would accept either of those 3 as a final answer. Okay, if you're not sure about that, please ask in class, because I know that might be a little bit on the confusing side right now. Alright, one more for the good of the cause. Here we go. Solve a equals x plus y plus z over 3. Basically, this is finding the average of 3 numbers. And what if you knew the average, you knew two of the numbers, and you wanted to know the third one? Well, basically that's what we're going to do here. Okay, so I want to know what x is, one of my numbers, and I got to get rid of the other stuff. Okay, well, yeah, notice this large fraction bar and the 3 underneath it. Well, basically that big 3 underneath this fraction bar is trapping all these guys. So the first thing I want to get rid of is the 3. And so since that 3 is in a fraction on the bottom, it's a division, so I have to multiply by 3 to cancel it out. Alright, those two guys cancel, and now I'm looking at 3a equals x plus y plus z. Now, depending on you personally, if you're really tricky about things, you can subtract the y and the z in one step, but that tends to confuse some folks, so basically I'm going to do this one piece at a time. First of all, I've got the x that I like, but I don't like the y, so I'm going to subtract y from both sides first. Alright, so those two guys cancel, and I've got 3a minus y on the left, and I've got x here, and I've still got a plus z as well. So basically I just have one more half a guy I have to get rid of, and, well, it's the z. So now I can subtract the z as well. And now I have the x by itself. And again, I've got a 3a, I've got a y, I've got a z, I've got all different letters, so I've got no like terms. So basically I've just got 3a minus the y that I had earlier, and now minus the z that we just did in this step. And again, I would accept this as is. He's wonderful, he's beautiful, but again, I just like the look of it with the variable on the left that I'm trying to solve for. So again, I would just simply recopy the rest of it and make it look, at least to my eye, a little bit prettier. Alrighty, so hopefully that made a lot of sense. If not, of course, ask in class, but here's 3 to give a shot at, and hopefully do well, and of course we'll talk about them when you get to class. See you there.